The normal distribution, the empirical rule. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. So far, we were dealing with discrete data. All probability distributions in the previous videos were discrete probability distributions. Discrete data is usually made up of whole numbers. Alternatively, we sometimes collect data using measurement. For example, we can collect the birth weights of all babies born in a maternity hospital over a year, heights of people, measurement errors, blood pressure, the length of cilia on a cell. All these measurements are continuous quantities. All these quantities are possible in a particular interval, not just whole numbers or certain fractions. In a continuous probability distribution, the outcome can be any value in an interval of real numbers and is best represented by a curve. One of the most common continuous probability distributions is the normal distribution, because it is widely used in natural and social sciences. Measured quantities such as age, height, mass, and lifetimes of batteries, etc., have a normal distribution. The equation of the normal curve is the following formula. The shape of the probability density function of such a random variable is bell-shaped. How this equation is derived is beyond the scope of this video. However, the following characteristics of the normal distribution should be known. A normal distribution with mean μ and standard deviation sigma has the following features. The mean in a normal curve divides the curve symmetrically. Therefore, the mean will pass through the highest point on the graph, and the mean, mode, and median of the distribution all coincide. The function is completely defined by the mean μ and the variance sigma squared of the distribution. This symbol denotes that the random variable x is normally distributed with mean μ and variance sigma squared. Approximately 68% of the data will fall within one standard deviation of the mean, between the mean minus one standard deviation and the mean plus one standard deviation. Approximately 95% of the data will fall within two standard deviations of the mean, between the mean minus two standard deviations and the mean plus two standard deviations. Approximately 99% of the data will fall within three standard deviations of the mean, between the mean minus three standard deviations and the mean plus three standard deviations. These last three features are known as the empirical rule. We now draw a few normal distribution examples using the empirical rule. A certain section of a forest has 400 trees. The trunk diameter of these trees is normally distributed with a mean of 120 centimeters and a standard deviation of 20 centimeters. Sketch a normal curve that describes this distribution. We sketch a normal curve. The mean of 120 centimeters goes in the middle. Each standard deviation is a distance of 20 centimeters. Approximately, what is the probability that a randomly chosen these trees have a diameter greater than 160 centimeters? The diameter of 160 centimeters is 2 standard deviations above the mean. We shade the area under the normal curve and add the percentage in the shaded area. About 2.5% of these trees have a diameter greater than 160 centimeters. Approximately how many of these trees have a diameter greater than 160 centimeters? We need to find how many trees 2.5% of 400 is. 2.5% of 400 is 10. About 10 trees have a diameter greater than 160 centimeters. Suppose that a pizza restaurant has a mean delivery time of 20 minutes and a standard deviation of 5 minutes. Illustrate this distribution graphically. We sketch a normal curve. The mean of 20 minutes goes in the middle. Each standard deviation is a time of 5 minutes. What is the probability that the delivery time is between 10 and 20 minutes? We shade the area under the normal curve between 10 and 20 minutes. So the area encompassed approximately represents 47.5%. Let x be a random variable which follows a normal distribution with mean μ. Given that the probability of x is less than μ minus 5 is 0.2, find the probability of x is greater than μ plus 5. Because the normal distribution is symmetric, it follows that the probability of x is greater than μ plus 5 is 0.2. Item B. To solve the item B, you should remember of the conditional probability of A given B. Now let's perform the calculations. It's done.